Hello everyone. I'll talk about this book today. It's called An Excursion in Mathematics. It's a very beautiful title. It's written by Modak, Katre, Acharya and Sholapurkar. It's published by Bhaskaracharya Pratishthan from Pune. From all that I hear, this is an excellent institution as well. So, before I go a little bit more into this particular book, let me tell you another book about another book which sounds almost the same. It's called An Excursion into Mathematics, but that's a very different book. I think it's published by an American publication. That's also a very excellent book. Maybe someday I'll talk about it. I learned that there are five and only five three-dimensional regular solids from that book, and there was a very beautiful number theoretic proof of this very beautiful geometric fact. I have talked about it in some other videos as well, but about that book I'll talk in a different video. So this one, Excursion in Mathematics, if you are preparing for IOQM, the first level of Mathematical Olympiads in India, if you're preparing for AMC 10 or 12, the American Math competitions, or NMTC competitions, this is one of the go-to books. You must try this one out. There are four sections in this particular book. There is a section on number theory, there is a section of algebra, there is a section of geometry, and there is a section of combinatorics. These are the four sections that you will need to master to really do well in the mathematical Olympiads. Now, the style in which they have written this book is very formal and problem driven. And this is a fact that I try to communicate to students all the time. They often ask me, can we not learn all the concepts first and then try the problems? Then I tell them, no, it doesn't work like that. And this is not me saying. If you go to, let's say, Art of Problem Solving books or this book by Bhaskaracharya Pratishthan, anyone who has been writing seriously on mathematical Olympiads will tell you this, that you have to do the opposite. You have to start by thinking with the problems. So if you look into this book, it contains a conceptual portion. There is a concept portion in this book, starting with the chapters, but the concept portion is also problem, theorem, lemma. It's structured like that. So, and you are, and the authors really encourage you to go into the proofs on your own before really looking into the text itself. And once you are done with these sort of theorems and lemmas and initial examples, and these examples, by the way, are all different from one another, they are not repetitive in nature. Then comes the exercise problems, which are the most important part of this book, the exercise problems. So there is a difference between exercises in mathematical Olympiads and exercises in regular school textbooks. And here is the difference. In school textbooks, usually there is a concept and then they give you 10 repetitions of the same concept in the exercises. So maybe they're teaching you factorization and you just do similar type of factorizations over and over again. That is an exercise in a school textbook. In a Math Olympiad textbook, however, each problem in the exercise is different, is distinguished from another one. They are not repetition of the same concept. So this is a very hard sort of learning style to communicate to students. They often think that, okay, maybe I learn a concept and I repeat it bunch of times and then I'll probably master it. That's not going to happen in this particular domain when you are at this level. You have to solve different type of problems over and over and over again, and none of them will be sort of repetitions of one another. You have to think fresh every time. And that's the skill, that's the strategy that we have to come up with. Okay. So you should definitely go through the entirety of this book, solve all the problems that are given here. There is a section on geometry, which I think may be a little bit, a tad bit less expanded than I would like it to be. So the geometry section actually is better in Challenges and Thrills of Pre-College Mathematics, which is, by the way, another great book. But the other sections, number theory, they talk about divisibility, congruences, theorems of Fermat, Euler, Wilson, and Lagrange, the greatest integer function, arithmetic functions, Pythagorean triples, representations of a positive integers, and so on. So all of these topics, they start with a few theorems and they actually then go into exercises. Of course, if you're learning number theory for the first time, if you've never seen number theory before, this style can be a little bit intimidating for you because there is not much motivation. They're not talking a lot about why you should think in a certain way. For that, there are two other books. David Burton's Elementary Number Theory is good, and the divisibility chapters of Mathematical Circles by Fomin, they are also very nice. So you should definitely check them out. But if you have some experience with number theory, then you can just come to this particular book and try the problems. Okay. And then comes the algebra part. It has four sections: polynomials, complex numbers, inequalities, and functional equations. I think all of these sections are quite excellent. Functional equations may have needed a little bit more expansion. I have talked about another book called Functional Equations by Venkat Shala, which is really nice in this regard. In geometry, there is triangle geometry and circle geometry. Excellent set of problems are given. I do miss the transformation geometry, which is not present here. Transformation geometry may include translation, may include rotation, may include inversion, and all of these tools. And that really opens up a different, beautiful genre of mathematics. There is a set of books by Yaglom, a set of Russian books available in English actually, which are excellent in transformation geometry. You can check them out. I can probably make a separate episode on them. And then comes the combinatorics portion. I think that's pretty strong here. The pigeonhole principle, principle of inclusion and exclusion, recurrence relations, all of them are covered in quite detail. So that's quite nice. The graph theory is missing a little bit, but that's all right. I guess for starters, this much is sufficient. For graph theory, you can probably go into Brualdi or Harari, a separate book for that. But this is sufficiently good for starting out with combinatorics. So this is an excellent book. Again, you should try this out and let me know if you have more ideas of books, other things that you want us to cover in this channel. And stay connected, stay subscribed, and if you like it, please like it in the YouTube channel. Okay, thank you. Bye. I'll see you in the next time.